We've seen lightning's deadly force. But what is it exactly that creates this awesome power? Our quest is about to take us to one of the world's stormiest places, with some of the most spectacular lightning on Earth. We've seen what happens when a storm unleashes its awesome power. Now we investigate what triggers this mysterious phenomenon. What happens in the moments before lightning strikes? Our journey takes us to a city that's home to some of the world's most violent lightning storms, Darwin, in northern Australia. In just a few hours, Darwin can take as many as 1,600 strikes. This is the perfect place to investigate the mystery of what sparks a lightning bolt. An international team of scientists have come here to find out. Using radar and a fleet of aircraft, they're looking for the answer deep inside Darwin's monster storm clouds. A potent cocktail of heat and moist tropical air means these are no ordinary clouds. Called cumulonimbus, they can rise up to 12,000 meters at speeds of 100 kilometers an hour. "20 kilometers up, twice as high as a passenger jet, a modified former Russian spy plane flies above the storm, collecting data about the cloud below. Somewhere inside this cloud, lightning is preparing to strike. Understanding how has puzzled scientists for centuries, but they think the cloud acts as a giant electrical generator.
Prior to lightning, the clouds need to be charged up, just like that comb attracting the water, which was negatively charged. Now, given the fact that we cannot create or destroy charges, how do we charge something up, positively or negatively? Charges can be transferred. The comb attracting water is negatively charged, which means that the negative charges are transferred to the comb. Before we transfer the charges, though, we have to liberate them from atoms. The negative charges are the ones that become liberated from atoms. The process of liberating charges from atoms is known as ionization. There are three ways we can ionize. The first one is the most obvious one, friction. The second one is heat. And the third one is light. What happens inside the clouds? Let's talk about that. What is the process responsible for the initial ionization of the clouds? The first thing that needs to happen is the clouds need to become ionized, which means that the charges need to become separated prior to lightning. Negative charges will sink to the bottom, the positive charges will rise to the top. So what process is responsible for the initial ionization of the cloud? Is it the heat? Is it the light? Or is it the friction? Is heat responsible for the initial ionization of the clouds? For that to happen inside the clouds, it needs to be extremely, extremely hot. And as we well know, higher up you go, the colder it gets. In fact, where the clouds are, it's ice cold. And that's one of your ice cold facts. Cute. Does lightning ever happen at night? If the answer to that question is yes, and obviously the answer is yes, so which means that the light cannot be responsible for lightning, because we would never get enough light from stars or the moon. I think the first thing we need to answer is, what are the clouds made up of? They look like cotton. Do you think they're made up of cotton? If they're not made up of cotton, where do you suppose we get the cotton from? Well, obviously the clouds are made up of water vapor. That is, vaporized water vapor that we're doing. So clouds are made up of water vapor. And the temperatures are extremely cold. So what happens to water when the temperatures are extremely cold? What happens to the water? It freezes. Water vapor freezes into ice crystals. So what do we have inside clouds? We have ice crystals. What happens to ice crystals? They go up and down. It's going to be windy there. Will be strong winds inside the clouds, so ice crystals will go up and down, and there's going to be a lot of friction among ice particles, and the friction among ice particles, ice crystals, will be responsible for the initial ionization of the charges.
Although lightning can reach temperatures exceeding 50,000 degrees Fahrenheit, these superheated bolts are actually created by ice.
That the ice crystals inside the clouds are responsible for the initial ionization of the charges. So just out of curiosity, I was just goofing around on the internet, and then I found this interesting article that says the scientists have witnessed the birth of an ice cloud for the first time. And this is all the way from 2016. And then guess what? There's a video attached.
Took researchers less than 20 minutes to create this ice particle, but documenting the moment represents months of hard work and a new beginning. With this experiment, researchers at Pacific Northwest National Laboratory witnessed for the first time at the sub-micrometer scale the birth of crystals that make up ice clouds. The thin and wispy clouds high in our sky are actually made of ice crystals. These so-called cirrus clouds play a major role in absorbing heat and warming our planet. That's why researchers want to know, where do ice clouds come from? To find the answer, they replicated the temperature, pressure, and humidity in our atmosphere inside a scanning electron microscope with one of the most finely climate-controlled chambers on Earth. In a space as small as a poppy seed, they witnessed water vapor forming ice onto a tiny mineral particle, a process known as heterogeneous ice nucleation. When a bunch of these ice crystals come together, you get a cloud.
People who work in this area, and they know that these are really, really challenging experiments, and behind the set of this nice image is showing the projection of ice crystals growing on the particle. There were like months and months work.
The time-lapse images will give scientists new insights into the formation of ice clouds, and they remind us that the very clouds that shape our planet's climate start out very small.
Alright, after the initial separation of the charges inside the clouds, what happens is the positive charges rise to the top, the negative charges sink to the bottom. So what causes the further separation of the charges? At that point, you're focusing on the ground. You notice that the ground is positive charged, so that may be an explanation. If you're thinking that way, I just set you up for failure. Reality of it is the ground is actually initially negatively charged, and for some magical reasons, the ground becomes positively charged only after the separation of charges inside the cloud. So the question is, what caused the separation of the charges inside the clouds? Why is it that the positive charges go to the top and the negative charges sink to the bottom? It's your turn. Now it's your turn to come up with a theory. So take all the time you need. I'm just going to give you one more second, and the second is up. All right. So whatever it is that you're thinking right now, it's going to be 100% wrong. So why don't we just go on to some of the theories that some of the experts came up with over the years. Okay, so one of the theories that we're going to be looking at is the following.
Inside clouds, air currents carry water droplets to higher, colder altitudes. As the droplets rise, they freeze into ice crystals. These crystals join to form hailstones. The heavier hailstones drop through the cloud, colliding with more of the smaller rising ice crystals. During these collisions, electrons break free from the ice crystals and bond with the hailstones. The rising ice crystals create a positive charge at the top of the cloud, while the falling hailstones create a negative charge at the bottom. Eventually, nature neutralizes the opposing charges. Essentially, lightning is a spark.
Oh, this one is super cute. So hailstones, positive charge hailstones. I'm sorry, the negative charge hailstones. Alright, let's just come again. Let's go over this one more time. So what do we have? We have the positive charge ice particles going up, and the negative charge hailstones sinking down. Perfect. So given the fact that both of them are chemically identical, why would the positive charges stick to the ice particles and the negative charges stick to the hailstones? Is that ice crystals will grab the positive charges consistently and hailstones will grab the negative charges consistently. And somehow every single lightning phenomena is going to have hailstones coming down. Does every single lightning accompanied by hailstones coming down from the sky? Yes or no? The answer is no. This is not a good explanation. And this is not the only thing which is wrong with it.